Good morning and welcome back to Let's Practice. Welcome to the series about single variable quadratic equations. So what is a quadratic equation? Okay, look at this equation. We have the variable x and the maximum power of the variable is 2. Here we have the power of 1 and here we have the power of 0. So the maximum is a power of 2 and that is a quadratic equation. To understand that creature, let's take a look at a parabola. Okay, this is a parabola. Well, all I did is instead of writing 0, I wrote the variable y, and every line, every point on this parabola, on this black line right here, satisfied this equation, right? So that is the definition of a parabola. So to understand what this is, let's take another line, okay? The line y equal to 0. That line, that green line over there. And just like we learned on the series on two equations with first degree variables, when we take two equations and we compare them together, we're gonna get the coordinates of their intersection points. The same is true about this parabola and this line. If I'm gonna make equal this line and this parabola together, I'm gonna get the intersection points, which is this point and this point. So let's set the y equal, and let's set the right side of the equation equal each other, and that equality right here, that is this equation. And from that we're going to get the solutions, the intersection points of these two equations. So that's what it is. So in short, a quadratic equation is just a parabola set to intersect with the y equals 0 line, which is the x-axis. Let's take this generic parabola, okay? This parabola could be anyone. I could set this value, this value, this value, and this value to any number I want, and we're going to get a different parabola, right? So to get this parabola, we're going to set y equal to 0 to intersect with the x-axis. We're going to set a equal to 1. I'm going to set b equal to -2, and we're going to set c to be -15. So this is how you're going to get a parabola. Now I misspoke, but it's not how we set a parabola, it's how we set a quadratic equation. Now let's continue talking about the predecessor to a quadratic equation, which is the parabola. We have here a parabola, and we have three options, depends on what values we're going to set a, b, and c to be. The first option is that we have no solution, meaning that the parabola is hovering above the x-axis, and it's going to have no intersection points and no solution. That might be, okay? That is a possible result of a quadratic equation. The second option is that we're going to have one solution, meaning that the parabola is hovering above the x-axis, but is intersecting only in one point, just barely touching. And the third option is that we're going to have two solutions. Okay, the parabola is intersecting the x-axis at 2 points. And that's all the options we're going to have. Most of what we're going to meet is option C and B, but we're going to demonstrate at least one time option A. Okay, so what do we have here? We want to find the intersection point, right? The solution to the quadratic equation. How are we going to do that? By using two methods. The first one is the trinomial method. The trinomial method, what we do, we're going to take the original quadratic equation, the original parabola is set equal to 0, and we're going to rearrange it to look like a multiplication of two factors, this factor and this factor, okay? And the second method we're going to use is the quadratic formula, which we're going to take the a, b, and c constants, we're going to determine what they are, and then we're going to plug them into this equation and get the result outside of what are the x1 and x2 of the intersection points. Okay, so for example, we're going to take an equation, rearrange it to be as to look like a set of factors multiplied by each other, and we're going to determine what the solutions are. And we're going to do the same with the quadratic equations. And on practice 1, we're going to mainly focus on the trinomial method, how we are finding both u1 and u2, which here is -2 and +4. And when we want to do that, and when we want to go to the quadratic formula, okay? There is a debate on when this is useful and when this is useful. They're going to give the same results, but we want a fast way, we want a precise way, we don't want to get confused, so there is discussion to be there, okay? So let's talk about the trinomial method, okay? We're going to expand on it, and we're going to practice it on exercises 1 and exercises 2. They're going to be also homework, so don't worry. But briefly, let's talk about the trinomial method. We're going to take some kind of a function, right? And then we're going to think. I want to know what kind of factoring I could do to get this result. So let's guess. X times x is x squared. Great. X times -2 is -2, and 4 times x is 4x. 4x minus 2x is 2x. So great, we have the factor here, and 4 times -2 is -8. Okay, so we can reverse it to see that we did the correct factoring. Now we're gonna make a demand. Here we have an equal sign, and here we have a 0. So in order for that to happen, this must equal 0, or this must equal 0, right? So what are the conditions for this to be equal to 0? Well, if x plus 4 is equal to 0, then we are satisfying this equation, right? So our first x is going to be -4. The second one is that x minus 2 it had to be equal to 0, which means that x is got to be equal to 2. And that is the axis of our solutions right here. Okay, so this is in briefly what the method is. And what we're going to do in practice 1 is to talk about how we find this 4 and how we find this -2. So stay to check out this practice 1. All right, good. So briefly on the quadratic formula. In the quadratic formula, we're going to focus on practice 3 and 4 and 5. Okay, so don't worry if this is too fast, but briefly, we have here a quadratic equation. Let's identify the factors, right? So we have 1 times x squared here. We have 2 times x, and we have -8 right here, right? I color-coded them for us to easily identify them. And all we're going to do, we're going to realize that this is 1, a is equal to 1, b is equal to 2, and c is equal to -8. And we're going to plug these 3 variables right here, 3 constants, right here. And it's going to look like that. So b, we're going to put it right here, and here it is. -4 is this -4. 1 is this a, okay? And -8 is this c. And here is a, 2 times 1. And this is b. So after doing that, let's try to solve this. 2, but for the power of 2 is 4, and -4 times -8 is 32, right? So we have 4 plus 42 is 36. The root of 36 is 6. And then let's utilize first the minus sign. So -2 minus 6, it's what we have right here, is equal to -4, right? So that is the first solution. And -2 plus 6 is this too, the second solution. So this is briefly how we are using the quadratic formula, and we're going to expand on it on practice 3 and 4 and 5. I almost forgot. In the middle between 4 and 5, we're going to have a bonus lesson, right? If you are interested, and I recommend that you will, I have a video about why the quadratic formula works. Okay, so stay tuned to see. It's a very nice geometrical, graphical solution, and it's going to make you realize why does this computation even work, which is the fascinating part. So stay along for that, and I'm going to see you in the next one.